All right, guys, so we've already looked at cosecant. Let's take a look at secant. So we're going to have secant theta. We're going to look at the graph of secant theta and some key features. And which graph is it actually related to? Well, in this case, secant is going to be related to cosine of theta. And the same strategies we use to graph cosecant are going to be the same strategies we use to graph secant. But instead of using sine this time, we're going to use cosine. All right, so first off, let's look at the domain. The domain of secant is going to be the set of all x's such that x is an element of the real numbers. Now we have to take out everywhere cosecant is 0. So we're going to say my x cannot equal, let's see, it equals 0 the first time at pi over 2. And then it repeats every pi k when k is an element of the integers. So there is my domain of secant. It's a little different than what you're used to, like I said, with secant. But there's an infinite amount of places where this graph's going to have a vertical asymptote, and we have to take all the vertical asymptotes out of my domain. My range is the same as cosecant. It's going to be from negative infinity to negative 1. We're going to skip over, and we're going to go to 1 to infinity. What we're actually skipping over is the graph of cosine. What's in this little middle part that we're skipping is actually the graph of cosine. Amplitude, once again, will not exist because there is not a maximum or a minimum to this graph. Therefore, it's not going to have an amplitude. And my period is going to be the same as cosecant because cosine and sine both have a period of 2 pi. Secant and cosecant will also have a period of 2 pi. All right, so let's take a look and see how this graph actually looks. So now, instead of me graphing a sine wave to assist me in graphing, I'm going to graph a cosine wave, which starts at a maximum. It's going to go down and then back up. And then it's going to go down and back up. All right. Now, this right here is 0. This right here is pi over 2. 3 pi over 2, and then of course this is 2 pi. This is going to be negative pi over 2. This is negative 3 pi over 2, and then of course this is negative 2 pi. Alright, now, just like the sine wave, initially we're going to look to see the x-intercepts, but what's more important is which points fall on the midline of my cosine wave. So right here, 3 pi over 2 is going to be an asymptote. Right here at negative pi over 2 is going to be an asymptote. At pi over 2, there's going to be another asymptote right here. And then at 3 pi over 2, there will be another asymptote. All right. Now, just like when we were graphing secant and cosecant, when we were graphing cosecant, wherever there's a maximum, that's going to make it opening upward. Wherever there's a minimum, we're going to draw something that looks like a parabola, and it's going to open downward. Wherever there's a maximum, which should be at 1 here, not drawn to scale, it's going to open upward. This one is a minimum, so it's going to open downward. And then right here, I'll draw half of it because I only have half of the period done. And there, ladies and gentlemen, is the graph of secant. Now, once again, I could erase this little part right in here, so you can see the actual just graph of secant. Or you can realize that secant and cosecant, the only thing that changes between them is what's called a phase shift. It's your C, it's your horizontal translation. And that's because the only difference between sine and cosine is a phase shift. So not only can I make a sine wave into a cosine wave, I can make a cosecant wave into a secant wave by just simply moving it left and right. And that's all you'd have to do. So let's look to see how to do a transformation on a secant function. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.